Well, hi and welcome to my shop here on January 11th. A very, very cold day here, basically minus 29 when I got up this morning. Yikes, that is cold. But not so cold here in the shop. I've given some time for this guy to warm up, and today what we're going to be working on, at least to start, is the trigger of the sweep. We're just going to be going through the process here and checking it to see if it's up to its proper operation. Maybe no adjustments needed in it. So, okay. So the instructions say to do this using the calibrated signal right from the scope. So I've got the calibrated output fed into the Y1 input here. And I have this set at 1 volt right now, so you can see a 1 volt display. And if I just turn the trigger control, oh, there we are, it triggers. Okay, now I think the idea is how small a voltage will it trigger on. I think it's kind of what they're interested in. So the suggestion is set the vertical to 5 volts per division. So now it's pretty tiny. You can see the trigger is still triggering, which is pretty good. It's just a little range there that's able to trigger on. Very good. My other scope won't trigger on anything anymore. So we'll just flip the plus and minus. And we'll look at the start of the to see whether it's changing. Yes, it is. Very good. Now, outside of the trigger range, on this scope, in some scopes the display will disappear, but not this one. It continues to operate, so that's what we're checking right now. Make sure it's still there. I guess I'm going to buy it. There we are. Okay, with a larger display, it's easier to find the trigger. I'm in Y1 and the balance is still not correct on it. That's why it's going up. Okay, so that passed the test, actually. Now let's try the same thing in the Y input here. Okay, we'll get rid of the one. Okay, so we're actually, so that would be 5 volts per division. We'll see if we can stop it here. Oop, I'm going to flip this over to Y2, so it'll trigger on the Y2 signal. There it is. Okay. There it is, flipping reverse. Very good. The display stays on the whole time. Very good. Okay, remove the calibrator from the Y input, set this input to ground, check that the time base runs free at all settings of level. Okay, so we didn't do that with the other one, we'll do it with this one. Set this to ground. We should continue to see a line no matter what we do here. These settings. Very good. Bring up the other one, put it on ground, and likewise, it's always there. Of course, it's always there. Good. Very good. There's no problem here. So I think that's the end of that. I don't have to make any adjustment to anything. The next thing is the ACF and the TV trigger. Now ACF means it's going to this will be set to AC, but with a filter. The F stands for filter. Now how are we going to check that? Set the Y2 attenuator to 1 volt, select ACF, 2 stable trigger points of opposite slope should be found in the level control. I mentioned slope. I'm using a square wave here. 2 stable trigger points of opposite slope should be found in the level control. Switch to TV, Y2 plus, and apply Y2 input. Apply to the Y2 input a video waveform from a video waveform generator. Yikes. I think that's something I don't have. So, and it's not really important at all. I'm not about to be checking any televisions, old style televisions with the video with a video signal. So I'm not going to worry so much about that. In fact, I'm not even going to worry much about this ACF. But let's do what it says. Set Y2 attenuator to 1 volt and select ACF. 2 stable trigger points of opposite slope should be found in the level control. Well, I guess I'm supposed to still have this signal in. Well, I don't see any triggering happening here. Let's check it on AC. What's happened? Oh, I'm triggering on the wrong input. That's the whole deal there. There we are. Okay, ACF. Too stable. 1, 1, 2, 1, 2, 1, 2. Okay, that seems to be what they're after there. To switch to TV, Y2 plus. Y2 plus. Y2 positive. Switch to TV, Y2 positive, and apply to Y2 input a video waveform from a video waveform. Yeah, I can't do that. So we just can't do this. So that passed the test. Let's try the other channel. Doesn't actually say to try this on Y1. Is this a Y2 only thing? Y1. We get this off, bring this on. There it is. ACF. 2 stable trigger points. 1, 2, 1, 2. Okay. That's great. And what exactly is being filtered here, I'm not quite sure. I did read about it, but I've forgotten. It's either high frequencies or low frequencies are being filtered away from the trigger circuit. Very good. External trigger with internal calibrate signal applied to Y2 input and Y2 attenuator set to 5 volts. And trigger selector set to external. Apply the calibrate waveform also to the external trigger via a 220 volt resistor. Yeah, I'm going to skip this. Never ever have I triggered my scope externally, and I don't see any need to do it. So I'm just going to forget the external trigger. And we're getting into more things here that I'm probably not really interested in. Pulse response. Switch the Y1 attenuator to 5 millivolts per centimeter. That's 5 millivolts per centimeter. Set the time per centimeter to 1 micro per, basically full blast. Full blast. 1 microsecond per centimeter. Apply 500 kilohertz fast rise time square wave signal to Y1 using a 50 ohm termination at the input socket to prevent cable reflections. Just output from generator. Okay. I'm going to stop and get this set up. It's a little more complicated than I had anticipated here, but I'm going to get this one set up. I think things are going to get a little more interesting now. So this is a test done with a high frequency square wave. That's what you're looking at on the scope. Doesn't look very square, does it? And the idea is you're making adjustments to repair these overshoots, but you have to have the cable coming from the signal generator, there's the signal generator there, properly terminated at the scope with 50 ohms. So in thinking about how to do that, I was going to take simply a Y splitter, a 50 ohm load, put it on, and put this on, and then put the cable onto here, and that, I think, will do it. But before I actually try that, I have an awful lot of these T connectors, which I got years ago from a buddy who was working for a big company that was making computers, and they were using these things by the millions, and he handed me quite a few. So some of these are squarish in here. Oh, this one's even different again. Huh. Some of them are also squarish, but this is larger. I never noticed that before. This is a square one with no top. This has a screw-off top here. And then I have some that are round ones. Then I have some PL259 versions of these. Now the weird thing is, I was using one of these when I discovered it was knocking the signal down. I thought this is just a straight through splitter, but it was knocking some signal down some time ago. I did a quick test and decided, oh, there's some kind of resistor inside here, and there is. If we pop this open, this was a surprise to me when I did this. Ooh. Feels as if whatever it is soldered right to this cap. Did I do a bad thing here by unscrewing this? Got a lot of these, so it really doesn't matter. Okay, so anyway, somehow I made the determination that there was, I thought, a lower resistor in here, and I just retired these. I just don't use these square ones anymore. But before doing this on the scope, I thought, here's another chance to take a closer look at this, because I didn't before. Let's put this one aside because I may have messed it up. Grab this one. Grab my ohm meter here. See if we get a little more light on it. So first of all, from pin to pin, through the inside. Now we're up 200 ohms here. So straight through on the conductor part. Now what about the resistance to the shell? So this is between the center conductor and the shell. Oh, come on, don't act up on me now. 55.8. Remember that number. 55K. 55,800. Let's try another one. I'm not sure what's going on. My leads are starting to fail. No, don't do this to me now. Not now. Not in the middle of doing this. 55.9, 55.8. Try another one. 55,000. I think it must be, maybe it's just this. There we are, 55.8. What is with that? 55.8. There's a resistor, 55,000 ohm resistor between the conductor and the shell inside here. So These ones, I convinced myself, were straight through in all respects. Okay, we'll go on the conductor here. Now, you're familiar with these things, and there's no surprises coming. Okay, that's the conductor through it. Fine. This is the shell. 55.8 again. Now, I have a lot of these. Some of them test exactly like this. 55.8. Can you quickly find one that doesn't? So here's one right here. This one is the way I would expect it. This is the one with the little square part. And through. 0. What's up with these things? So I'm going to have to be a lot more careful. I've been using these left and right, and the assumption is all these are straight through, when in fact they may not be. So no resistor there. And why 55.8? Okay, so we think we've got one here that is straight through. So what I'm going to do, I'm going to stick it on here. See what it looks like on the scope. Okay, very same. Now we're going to terminate it with the, I know for sure this is 50 ohms. Termination here. What happens? Well, it's a lot better, but it's not perfect. So I think I'm in a situation now where I'm ready to do what they're suggesting. And wow, does this scope need it badly? I'm sure it shouldn't look like this. It should look quite different from that. Here's that. I'll look straight on with the straight on camera. Well, now the adjustment for this, I have to read up and find. Let me just try a little focus here. No, that's focused. Okay, I gotta just read up a little more, and then we'll do the adjustment that's required. Okay, we gotta hold the fort here because I was making an assumption. I'm assuming this signal generator up here, which I've never ever done anything with except use, is producing a beautiful square wave. So I'm gonna give you the scope view here, and then I'm simply going to turn the input up and down, or the output rather, of the signal generator up and down. Well, that's curious. Now this signal generator comes with pads, so I'm going to put in a 30 dB pad, and then I have a vernier I can turn up. I get basically the same sort of look. Well, let me just take off the 20 dB pad. Well, what is it? This is a very low output. In fact, that's just about as low as it can go. Let me take off another pad. I don't know what to think now. I have another scope. Why don't we throw this onto another scope? Now I'm assuming the output of the signal generator is 50 ohms. Probably is. Not sure that makes a difference. I'm assuming the way that I've got it terminated here is appropriate for what I'm trying to do. If I'm going to move this up to the other scope, up above there, up to this one here, and we'll just take a look. Do it right now. Probably give some time for the scope to warm up, but I'm not going to. Okay. Now, oh, the difficulty with this scope. Let me change cameras here again. Oh, can't. Can't change cameras. Okay, looking with this longer range view here, I only have so many inputs I can operate with the software I use to make these videos, and this camera's not on right now. So the problem with this scope is it won't trigger. So it's going to be very hard to get a look at this thing that's on here. I think this is way too that's very, very high frequency. Yeah, how am I going to freeze this? This is not going to work out. What was that? What was that funny noise? Well, I'm not seeing anything at all. Make sure I've got what I think on there, yeah. Well, let's slow down the signal generator. It's running at around a megahertz. Okay, now I can see something. Let's speed this up. No, I'm too slow. Yeah, speed this up. Try to freeze it. Here we come. Well, I don't see any wildness there, but wow, this is really a hassle. I don't see any disturbance in there. But this isn't up as high. Let's go higher. Nothing showing up. It looks square. Okay, let's go a little higher. Now this is going to be really tough. Yeah, I'm not going to be able to do this by hand. So what's in the back of my mind is, should I bring the scope down and work on the trigger control for it? It could be everything from just an adjustment to defects in the actual circuitry. And it's a complicated scope compared to the one I'm working on. That's what's in the back of my mind. Well, from what little I saw here, let's take this down one notch and then see if we can freeze it here. Again, at the highest frequency I can get it stable. There it is. There's nothing funny going on. Okay, so right at this setting, at this speed, whatever it is, let's put this back on the other scope. But I think this is telling me my signal generator is not producing the effect that we're seeing. Okay, we'll go back to the other scope here. Well, that was pretty lousy view in the camera. Sorry about that. Let's see what we get here. Turn the brightness down a wee bit. Slow this down a little bit. Wow, it's hard to say. So this one shows an overshoot, quite clear. I did not see on the other scope at this frequency. I think there's a problem with this scope, and that's what's causing that. Could it be bad termination, the way I've done it? Yes, it could be. Can we go higher? We're at 5 microseconds here per division. That's pretty fast. And the frequency we're at is 50,000 hertz. That's not terribly high. Well, since this one triggers, it's easy to go up and get a stable look. So let's go up by a factor of 10, basically. This is now 500. And those look bigger. Let's go back. This is interesting. Let's go back down. They look the very same. And we'll make this go a little quicker. And a little quicker. The scope's working really nice. This scope is working really nice, except for those peaks, which appear to be inherent in the scope itself. Okay, let's do the adjustment. I got to read up again here. Okay, the two adjustments here are C209 and C211. Here and here, there and there. So which one is first? I can't remember. Let me just reread that one more time here. Adjust C211 to extend flat top towards leading edge. Adjust C209 for square corner. Apply the signal generator Y2. Apply the signal generator Y2 to check. A little bit of grammar problem there. To check squareness of the corner. And readjust. So they're just saying move it to the other input and then find the best average of the settings on both inputs. I guess they're a little different from input to input. Is that so? Let's take a look at that before we do anything. So here's the view of the scope, and what I'm going to do, I'm going to bring up the, this is the Y2, put it up here. I'm just going to move the signal over to that one. It's the way to focus, isn't it? Okay, it's on there. And we need to set the sensitivity way up. What's happened to the focus? There we are. And I'm going to trigger on Y2. I get exactly the same kind of look. Oh, there. That's focus going back and forth, and you can see the astigmatic effect. I just made that word up. This is a better way to adjust it. I should go back and do this astigmatism again. It looks like I could make an improvement. Let's carry on with this particular thing. Now I can stay in Y2. There's no reason I have to go back to Y1. So Y2, and it was 211 to extend the top. Well, let's just move them and see. So I'm going to do 209 because I think 209 is the one that's going to benefit the situation. Here we go. This is 209. Well, it's not going to get much better, is it? What I'm trying to do is reduce the overshoot there. Okay, and this is 211. Not making much difference at all. So we're at the most sensitive volt setting and the fastest speed this scope will do. That's giving a wonderfully stable display. But I'm going to fool around with the output level again coming from the signal generator. It actually seems rather consistent in its look. Yes, I can point to it. So I see a curve right in here. This is difficult for me to right in here. Curve, right, that curve right there. So the flat part isn't really flat. Let's just not worry about the pulse thing that's happening there. So this is 11. Does seem to fix up the corner a bit. And this is 09, 209. Well, that's what we're going to get there. We are up at the limit of this scope. And just the fact that it's beautifully stable is kind of good news in itself. The actual frequency I'm sticking in there right now is 500 kilohertz. So 500 kilohertz, similar to the IF in an AM radio, which is at 455 kilohertz. So if you did this with a sine wave, you might not notice anything funny about it. He says, so just push this button. Yeah. So looks like the bottom of it is just a little pointed. That's what it looks like, the bottom of the sine wave. If you stick a triangle wave in here, looks like there's a bit of a curve right up in the top part here. Just this part right in here. But that could just be my eyes, the way I'm looking at it. It's not much of anything anyway. I go back to the square wave here. Well, based on the fact that on the other oscilloscope, these are both, I believe, 100 megahertz scopes. Maybe this one's only a 10. I can't remember now. The other one's definitely 100, and it shows a nice square display. So I think we're just at the limit of the scope. I don't think there's much I can do about this. I just read a little further on the instructions, and it says allow for a 4% overshoot. 4%. Well, this is a lot more than 4%. This is, of this whole line, this is 20% anyway. Quite a bit more. It also says to step this down frequency-wise. So we will do that. Just going down in frequency. So this is the sweep, slowing down, so you're seeing more of it. Now I'm slowing down the signal generator. Ooh. Oh yeah. Shouldn't have done that. Oh yes, it should. Okay, no problem. Let's slow it down some more. You can still see those peaks. And I'll slow down the signal generator a lot. Now, hard to see them. They're there though. If I turn the brightness up, maybe we can still see this little tiny peak and overshoot. Now, there was another adjustment I did that affected that, wasn't there? Huh. Okay, I'm going to stop and just review some earlier settings. So I've gone back to a step called input capacity and attenuator or something or other. And I'm going to adjust, we're looking at this, C201 and 202. That would be for Y1. We're looking at Y2. So it's going to be C221 and 222. Just see what happens here. So this first one is 222. Okay, my tool's in. Here we go. Just turning it back and forth a little wee bit. Not a thing happening. Okay, and now this would be 221. Okay, here we go. Not a thing happening. Okay. I think maybe we're just looking at one of the limits of this oscilloscope. Certainly after all these years. I wish I got a little bit of overshoot too, probably at, where I am in the scheme of life. Okay, I'll turn this down a little bit. I think that's the best we can do there. Next item. Okay, the next one is a bandwidth check. And what we need to do is put onto the scope a signal of 50,000 hertz. There we are. That's 50,000 hertz. Set this up for bigger display. Got this set most sensitive here. Okay, bigger display would be more output from over here. Okay, maybe just speed it up a touch. Now, the idea is, if I adjust this so it's exactly, let's just go just a wee bit higher. Okay, that's what 50,000 looks like. Maybe we should do this with a sine wave. 50,000. Just put it in the middle. Whoops, wrong one. Okay, now we're going to raise this frequency up, and it should be good past 10 megacycles. My signal generator doesn't get there. Wrong signal generator. Okay, well, using this one anyway, we'll go up to what it's got, 5 million. So the idea is the size of the, let's go on the other camera. It should keep showing that size. Now, how do I know for sure my signal generator isn't changing? I don't. Yeah, that's why in the instructions it says using a constant output signal generator. Well, I don't know that this is constant output. And it got bigger. I don't know. I don't think I can pull this one off. I don't think I have the equipment to do it at all. But that's what that's 5 megacycles going through there. So obviously 10 is the limit. It says you should be good to 10, and then above 10 it should start rolling off. So this is a 10 megacycle. 10 megahertz scope. I'd have to use the other scope, and what am I going to do about it? It doesn't even give instructions on what to do about it if it's not good. I have the feeling if it's not good, there's a defective component or something. So keeping in mind that this is a 10 megahertz scope, staying below 5 should be good. Typically, what am I using this for? I use it, believe it or not, to look at the ham radio signal going out on my antenna. So I am transmitting at quite high frequencies, come to think of it. Quite high. I was using 21 megahertz the other day. That's way beyond the range of the scope. That's something to keep in mind. So by the time you get to 21 megahertz, this thing would be shrunk way down. All that calibration stuff doesn't mean anything at that point. Okay, just learning along. I have another scope, but its limit is 5 megahertz. It's even weaker. And I have a couple of really old guys, which we'll probably take a look at some point. I think for now, the most I can say is this scope's good to 5 megahertz, and beyond is, for making quantitative measurements, which I seldom do anyways, not so good. So the next test is simply to check for a stable display at very high frequency, and we've already done that. We found that the scope triggers fine and puts a nice stable display on at high frequency, so that's not a problem. The next one is the XY setting, so we're going to check out somehow. Okay, so the idea of this test is you have the scope set to XY. I'll show you what's on the screen here. You apply a signal to the Y1 input. That's what's causing this line. You apply it at about 50 kilohertz, and you set the output of the signal generator to give you some kind of display. You then increase the frequency of the signal generator and watch and see that the line doesn't shrink. But the problem for me is I don't know that the signal generator maintained the same signal level as I did that. And it's supposed to be good up to 500. I believe it said. Should be. It's going to shrink a bit. I think it's 1 centimeter at 500. So at 50, you've got this. At 500, you've got that. That's roughly what's happening here. I'm at 500 now. So, again, and then there's no statement of what to adjust. It's just a test to make sure the scope is operating within standards. There's really nothing much I can do about it. Again, I think for an old scope, the performance of this thing is actually pretty good. Well, the last check is to test the Z input, which is on the back of the scope. The Z input will control the brightness of the screen. I've never used the Z input on any scope ever, so I'm not even going to bother checking it because I'm pretty happy with the results I've got now. It's a good time to quit right now. So that's fantastic. I'm really pretty happy with that. So remember, I got the scope from someone's driveway. They were basically offering it to the public, and I'm the public that got it. And I relied on the scope for a few years. I really like the triggering. The triggering is rock solid on it. It's fantastic. This other scope, which is actually a far better scope up here, because the trigger has failed on it, it's failing on it, it's failed on it. It's really the way it is. It's a problem to be used in my shop here. So I got to think hard about what I want to do. Do I want to dig into this complicated machine in hopes of trying to fix it when I think it's a bit of a fat chance? The other thing that I think is kind of interesting is, what about all these connectors here? I'm going to have to go through all my connectors and mark them somehow. What is going on? Now, these were really used by a company which was making industrial computers. This would be 30 years ago, something like that. And they were using coax cables to connect the different modules of their computer system and using these for various purposes. So maybe this is terminated inside with a 55,000 ohm resistor because that made sense in their application. Whereas in normal RF work, radio work, if anything, it would be 50 ohms. I don't know. It's 55.8. Never heard that number before. I'll have to go through them and check them. Be a little more careful with them. In most applications, 55,000 ohms isn't going to do much. If you're using a 50 ohm system and you use one of these, that 55,000 short, I guess you could call it, isn't going to do much, I would think. Must be something important about terminating these things at that level of resistance based on their use in a computer, I guess. I don't know. All surprising to me. So, I'm going to end it right here. So thanks a lot for watching this. What I'm going to do next, I don't know. A couple of days before radio shows up here. Thanks. See ya.